So the first thing we always want to do is just draw a picture. There's no better way to get a handle on what's going on here. And there's not going to be some quote-unquote method. You just gotta take what they give you, put it on paper, and see where it takes you. So let's go point by point. It says there's a solid whose base is a region. Okay, I'm going to stop reading and just recognize there's a solid. That means I'm drawing in 3D, and the base is in the plane. So I'm going to draw it nice and flat like this, so we'll be able to see what's going on. It's in the first quadrant, so I draw in blue my axes here. Y equals x squared, I draw that one, and y equals 1. It also says y-axis, but we already got that because of the first quadrant. And then it says the cross-section is perpendicular to the x-axis. Before I even read the last part, I want to identify what that is even going to mean. So I draw a bunch of lines in a different color. These are going to be the cross sections, right? You're taking these slices, and then it says they're squares. So finally, let's just draw one or two of those just to get a feel for what those are going to look like. I'm not going to draw the scale because it won't fit exactly, but pretend these are squares. We just need the basic geometric idea. Okay, so you've got a bunch of squares of different sizes lined up next to each other. And like I said, not to scale, but you're going to have a really strange looking wedge shape. Oops. Although the exact shape won't matter too much because we're just going to be dealing with, mathematically dealing with the squares and going left to right. So what we want to remember is that volume and area always means we're taking an integral. And integrals are made from Riemann sums. You may have thought that those are maybe like the worst part of this class so far, but they make integrals much more flexible. You can apply it to all kinds of stuff. So remember, the idea is just to break it up into these slices with a little bit of thickness, right? We're kind of making these layers that we're going to find the volume of. Okay, so the idea here is this is just one of many layers up next to each other, and if we add them all up, we will get approximately the volume. When you take the limit, you'll get an integral, you'll get the actual volume. But the first step is just to find the volume of one of these squares. Remember, they're squares, not rectangles. So it's a rectangular prism or box. Technically, it's just very thin. So what's the volume of it? It's height times width times depth. Okay, so we just have to identify each of those. Remember, it is a square, so we have h and w are going to be equal, and then the depth here is going to be the width of our little integration slice, so that's always going to be delta x. Okay, so we have width squared, delta x. I just picked w. H could have been fine, but I felt like W was more tied to the actual graph right here. So we don't have to worry about what delta x is. We do have to figure out what W is, and that is the length going from here to here, right? So what's this distance? It's 1 minus the value of the parabola, and so these are y values, right? So 1 minus y equals x squared. So W is just equal to 1 minus x squared. Okay, so from there, it's not, this is the easy part. We just take this W and plug it in there, and then we take this VI and plug it in there, and we get the Riemann sum that we are after. Okay, so pretend these slices are very thin. We're going to get a close approximation of V. The only thing left to do is to, quote, take the limit. I didn't write the ends, but you get the idea. So the integral is going to be adding up all these slices from the left to the right. So what are the x values? There's 0. And over here, we'd have to set 1 and x squared equal to each other, so that's going to be 1. So we're going to integrate from 0 to 1. And then if we simplify this expression here, we get that. And then when you take limits, the delta x turns into a dx. That's really just convention. Don't have to worry too much about what it means. And then this integral is just something you can take using all the integral rules you've learned at this point. So I hope that helps. Just remember, it's much easier to build these things from scratch with the sums than it is to worry about formulas or anything. So there you go.